Hello everyone and welcome to Roadmap. So today's topic is light part 1, and if you like the video don't forget to click on thumbs up button below, and you can also subscribe for more video updates, and you can also share, and you can also give your suggestions in the comment section below. So the topics to be covered are introduction, rectilinear propagation of light, demonstration of rectilinear propagation of light, reflection of light, real and virtual images, mirrors, lenses, Newton's color disk. Now coming to the introduction, I'll just tell you that what we are going to learn in this chapter basically, or what we'll be able to understand after learning this lesson. You will be able to know what is light, to understand how light propagate, to construct different types of images with concave and convex mirror, to analyze the difference between concave and convex lens, to evaluate the splitting of white light into its constituent colors, and to show the splitting of white light. Now, coming to the introduction part, first tell me what is light. Think over it and give the answer. Now, if you enter a dark room, the objects present in the room are not visible, right? And if you switch on a bulb, everything in the room becomes visible. Now, why it is so? Why the bulb gives out an invisible energy, and this is called as light. When this energy falls on the objects in the room, it bounces off from the surface of objects and enters our eyes. The eyes sense it and send the message to the brain. It is finally the sensation in brain which really sees. Eyes are only an aid in seeing objects around us. Now, light is an invisible energy which causes the sensation of vision in us. So this is what light is exactly. The invisible energy is called as light, which bulb gives out. Coming to rectilinear propagation of light. Light travels in a straight line, that is called as rectilinear propagation of light. And formation of shadows and eclipses is the direct consequence of rectilinear propagation of light. There are quite a number of everyday experiences that can be explained on the basis of rectilinear propagation of light, such as formation of shadows and eclipses can be explained on the basis of rectilinear propagation of light. When a beam of light, sunlight, enters into a dark room through a ventilator, the path of light appears straight. This is also an example of rectilinear propagation of light. Then the formation of day and night can be explained by rectilinear propagation of light. And a small laser torches are used as pointers are also the example. So these are some of the examples of rectilinear propagation of light. Now coming to the reflection of light. When a ray of light, while traveling from one optical medium to another optical medium, strikes the surface of separation of the two media, the following situations can be arise. 1. The ray of light may be returned by the second optical medium into the first optical medium with a change in angle, and this is called as the reflection of light. And the ray of light may get absorbed by the medium. The ray may pass through the second optical medium with a change in angle, and this is called as the refraction of light. So it may be pointed out that all these phenomena can take place at the same time. That is, a part of light energy can get reflected, a part get absorbed, and a part get reflected. The return of light into same medium after striking a surface is called as reflection. So from this figure, you must be getting that the moon is reflected in the water. You can see the reflection of moon in water. So it is an example of it, and you must be clear that what is reflection of light exactly is. Now coming to the laws of reflection, there are two laws of reflection. When a light ray falls on a plane mirror, the light ray reflects off the mirror. So from the figure you can see that. And reflection involves a change in the direction of the light ray. According to the laws of reflection of light, the angle of incidence is equal to the angle of reflection, and the incident ray, the reflected ray, and the normal all lie on the same plane. So this is the law of reflection of light, and from the figure you will be able to see that angle of reflection is equal to angle of incidence, and the incident ray, the reflected ray, and the normal all lie in the same plane. So this is law of reflection. Coming to the difference between real and virtual image. When rays of light from an illuminated object are reflected by a smooth polished surface in such a way that they actually meet at some other point or on a screen, then the image so formed is called as real image. And if the light rays after reflection appear to meet at some other point but cannot meet on the screen, then the image so formed is called as virtual image. Both the real and virtual image so formed may be of the same size or bigger or smaller than the object. So the differences are: real image, it can be taken on the screen; virtual image, it cannot be taken on the screen. Real image is always inverted, while the virtual image is always erect but laterally inverted. Real image, the rays of light after reflection or refraction meet at a point, and virtual image, the rays of light after reflection or refraction appear to meet at a point. So I hope you are clear with the difference between real and virtual image, and what is light and what is reflection of light, and then laws of reflection. So if you have doubts, you can give your suggestions in the comment section. You can write them. I'll try to clarify them, and I hope you are enjoying the video, and stay tuned for more lessons to come. In the next chapter, we'll learn about lens, what is concave lens, convex lens, then about the mirrors and Newton's color disc. So thank you for watching.